Thank you, and good morning. Let's wait for a minute for this to set up. I just want to thank everyone for coming here this morning, and also want to thank organizers for having me here. I think the first one, or that was actually the first WebCamp conference that was organized was 2012, I think, and I attended it, and I really fell in love with WebCamp, so it's a real pleasure to be here again. Before we start, I'll mention a lot of resources, links, papers, things like that, and I'll go quickly through them. But at the end, I'll provide a link where you can find all of them. So you don't have to take photos and write it down. Everything will be in one place. What I want to talk to you today is the fact that you'll likely have a very different job in 20 years from now. And the problem is that you don't know what kind of job it's going to be. Nobody knows. The rate of technological progress is steadily accelerating. It took us thousands of years to master agriculture, wheel, and writing. Only hundreds of years to master printing press, steam engines, and electricity. And only decades to master nuclear energy, internet, and computers. While this progress is really good for humanity, it's a bit anxiety-inducing for one human being. The time when you would learn the trade and practice it until the end of your life is long gone. Today it feels like there is a new development every couple of weeks, every couple of months. And not a lot of us here have time, resources, or even desire to reinvent themselves every time this happens. So the question for us today is, if we don't know what the future is going to look like, what skills should we acquire now, and what skills should we avoid? My journey to answer this question started about 20 years ago. And it started with this. Who knows what this is? Wow, that's good. So this is Fallout. And Fallout is a famous role-playing game where you start your game, you build a character, and as you gather experience, you improve your skills, your attributes, you find better equipment, you tackle on more complex challenges. And at the end, you finish the game. And I really loved playing Fallout. I played it a lot. And I remember one afternoon, I stopped playing, I stood up, and then it hit me. If I start a new game, Fallout, I have to start over from scratch. If I start another game, not Fallout, something else, I also have to start from scratch. So all the skills, all the time I invested in learning those skills here, they're wasted. And even though I wasn't able to verbalize it then, there were two big changes that I made. The first one, I reduced the time I played my games. I didn't stop, I really love playing games, but I just reduced it. And I decided that I'll spend more time playing the games of life. However, it took me about 10 years more to really see the patterns and try to understand the scope of the problem and try to answer it. And it started with changing jobs. As the same said at the beginning, I changed a lot of jobs in different roles. So this is how it looked like. So I first started with software development. And the green bar you see, that's the full range of skills I had to use to do my job properly. After some time, I started another job. And what was interesting is that I could transfer most of my skills. So it was a very similar job in the same domain, but there were some things that I still have to learn, something that were very specific to the job. But because it was a similar role, most of the skills I could reuse. Then sometime in mid-career, I decided to change the role. And I went from the software developer to UX designer. And what happened is this. I was able to transfer only some skills. And it felt like I'm starting over, but I actually wasn't. I was able to transfer something. But then the rest I had to learn. I had to do a lot of catching up to be able to do my job and to also be of help to my colleagues. And then, after some time, I joined Google, and it was the same role. And it happened similar when I just switched inside the domain. I was able to transfer most of the skills. And then the rest that was very specific to the job, I was able to catch up quickly. So you can see a couple of patterns here, right? And one side is something that is always transferable, either inside the domain or outside the domain. Then there is this middle part that is only transferable inside the domain. And then there is a small part that is very specific to your job. And I call them foundational skills, and I call them domain skills. And we'll cover both of them in more detail. And let's start with the domain skills first. Because there are so many different domains, so many different industries, it will be impossible to cover all of them now. So what we'll do, we'll take just one example and try to build a model that you can reuse. It's not going to be a perfect example, it's not going to be a very extensive example, but we have to start from somewhere, so just keep this in mind. And it's going to be from software development. Imagine you're just starting out, and you want to work in a specific company. And that company uses Django. And Django is a web development framework. And you learn a bit and you find out that it's written in Python. So you'll have to learn the Python language, the syntax of it. And as you explore, you prepare for the job, you realize that actually there are some other frameworks you can use if you know Python, right? So it's not just Django, it's Flask. And there are other things. Now, machine learning is very popular today in Python. So if you know Python, you can use something else. But to learn Python, when you're learning this, you're not just learning the syntax of the language, you're also learning the traditional programming structures, conditionals, variables, functions, classes. Those are the things that are really in the language. But as you learn them, you realize that if you look at other languages like Java, they're using pretty much the same thing. So you're not starting from scratch, you're able to reuse your knowledge of the structure in other languages. And then Java has their own frameworks. So that's interesting. And there's some reuse there. So now you're learning the language, and you're being able to program, but what you're learning is the algorithmic thinking part. Can I take a problem, and can I break it into steps? And can I write the instructions to solve this problem? And you've been using this example, for example, Python, to write the program, the scripts, and it runs, and it solves the problem. But if you learn the way to break the problem into smaller pieces, you can also use different methods of solving it. For example, in robotics. I don't know if some of you played with Lego Mindstorms, but there is a different structure of solving problems, which is very different from the traditional programming languages, but you can still use that to solve the problem and accomplish the goal you want. So it seems that this algorithmic thinking part is used across different areas. Okay, now you learn to program, you know how to solve simple programs, maybe you can do it in different languages. So what's next? Well, as you spend more time in software development, you need to build something more complex. And then technical system design comes into play. How do you structure the whole application? What are the interfaces? What are the communication layers? Maybe you need to build multiple applications that talk to each other, right? Maybe they're very complex and big systems. And building this, learning this takes time. This is not an easy skill to acquire. It's also one of the skills that's very close to system theory in general. What are the feedback loops? How different systems think? And if you learn this, it's so broad that you can use it in very different environments. For example, you can build automated warehouses or fulfillment centers. They also work as complex systems. And when you look at this branch, just one of the examples, but there are a couple of things to notice. It seems like things on the right are leaves, right? They're very specific to the application. But then as you go up the branch, it gets thicker and it supports more skills. And it can be used, it branches out, it can be used in more contexts. And for you to do your job, you will need skills from the whole branch, right? You cannot just learn system theory and be a good programmer. You need the whole branch. But when you talk to really senior people in the field, you ask them what's really important in software development or software engineering. And they will usually say it's being able to manage complexity, making good compromises. So that complexity doesn't kill you as you build things, as you add people, as you work on something. Is it maintainable? Is it testable? Those things are really hard. And those skills lie in the technical systems design part, not in the syntax of the language. So if you really want to pursue mastery, you need to learn things that are more on the top left. You probably never met a person who is a really, really good programmer and they can write only simple scripts in 10 languages, right? So think about this. What are the skills in your domain that you can learn that are very transferable? If we take this for design, things on the right-hand side, or those live skills could be, do I understand Android or iOS guidelines? Or do I know how to use Sketch or Figma, right? These are things that are really specific to the job or to the current situation. But understanding the human psychology, building out the mental models, building good flows, understanding human perception and memory, those are things that you can use in design in any kind of environment, on print, on a mobile device, in VR. It's very transferable. So now when you have the model, how can you find those skills in a better way? So there are a couple of things. You can always talk to senior people in the domain, and you can ask them, what has changed and what has stayed the same? Things that have stayed the same are probably very hard to do, and it makes sense to invest time in those. Things that change a lot are just situational. You can think of them as leaves. They just, every season they fall off and the new grow up. So talk to senior people. It can be in a form of formal mentorship. It can be in a form of informal mentorship. Just grab a coffee with someone and talk to them. Another good way of doing this is that you can talk to people who work in adjacent domains and see where are your skills overlapping and what is very different. So the farther the domains apart, you probably meet closer to the trunk, not so much at the branch. But you can find what is really important there. And one that I really love is just reading all publications and books. And old will depend on your domain. In development, it's going to be something that's old, might be 50 years. In something else, some other domain, it might be 300 years or 1,000 years. So it's very relative. But read what was challenging before and see what are the struggles people had there. One interesting example is I read Mythical Man Month. It's a collection of articles that were written in the 70s from experience of doing software design on operating systems in the 50s and 60s. And they, for example, one problem they had is just couldn't fit the program in the storage they had. And today we don't have this problem. It's not a problem anymore, right? And this was a real struggle then. And if you really optimize your knowledge for how to fit a small program into something, it's not as relevant today. But also had the other problem is, even then, is how do you write something that's maintainable? How do you write something that is testable? How can many people work on this and still be organized and still finish this in time? That was a problem 50 years ago, and for you who work in teams, you know it's still a problem today. So it seems like it's more relevant skill, more important skill, a more longer-lasting skill than anything else. Going back to the split, so I'll talk now about the foundational skills, because I think these are really important. They serve as amplifiers for everything else you do. And you can transfer them to any domain you're working on. And I'll show them. I don't think you'll be surprised by them. There are communication, creativity, collaboration, and critical thinking. But I'll go deeper into each one and explain what are the component parts and why they're really important. One reason why they're here is that we have this second wave of automation with machine learning and artificial intelligence. And there are different predictions what will happen. But people in the field say that we are way off from something that is human-like. So it's going to solve narrow problems. And machines still struggle with this. So if you're really good at this, you will be able to take this for a long time. What I'm not going to talk about is how to learn. So that's one of the meta skills, because you can improve the rate of learning. And you will have to learn for your job, and if you change your role or job in the future, you have to learn all the time. So I will not cover this, but there are techniques of how you can learn more efficiently. And also I will not talk about health and well-being, but this is really, really important. And I know that many people neglect their health and well-being, but for you to be able to learn and to perform well and to be good in any of these skills or even your domain will depend very much on your health, physical health and mental health. I think it's something to keep in mind. So let's start. And let's start with communication. And you know that communication is really important, that even in the post-apocalyptic world is there, right? You have small guns, big guns, explosives, medicines, and communication. So it's really important. But communication is very broad. And we as humans, as social creatures say, oh yeah, but we are really good at gossiping, so we know how to talk. But there are some component parts I think we should be aware of. And the first one is being able to clearly articulate ideas. How many of you have been in meetings and presentations where people would just talk and talk and talk and talk and talk, and you have no idea what they're talking about? I see a lot of nodding heads, right? It's really hard to come up with a clear idea and communicate it, and you can practice it. And a good tool for practicing it is actually writing. Writing is, you can externalize your thoughts and you can look at them. You can edit it. And then when you're happy with what you're seeing, you can take it back and then you can say it out loud. And I'm really sad that I went to school for 16 years and nobody taught me how to write. They taught me letters and some grammar. Nobody taught me how to write well. So I had to take up books, find mentors, practice, publish things online. Most of it's really bad, but it's good for getting feedback. And writing has been one of the transformative skills in my life, for my career, but also my private life. And I think everyone should really invest time into writing. And just to be clear, writing is really hard. Of you who have tried it, you know it's really, really hard. The second one, couple books. Keys to get great writing. It will help you how to write nonfiction. Technical documentation, stories, presentations, CVs. And then also Steven Pinker is Sense of Style. The Sense of Style, it's a really good book of how to write in a nice way that's easy to read and also correct. It's very focused on the English language. So I don't know about other languages, but this one is really good for English. The second thing is public speaking. And by public speaking, I don't mean things like that, where you stand and talk in front of people, which is also part of that, but any kind of speaking in front of a group. It can be a workshop, it can be a meeting at a company, it can be, you can teach somewhere. So any kind of speaking where you present your ideas to a group, you can practice. And here it's not just content, but also your posture, your voice, your presentation. And these are things that are really physical and you can practice them. You wouldn't believe it, but listening is a part of communicating. And this is an interesting one because you will be perceived as a better speaker if you talk less. And not only that you will be perceived as a better speaker, you will be a better communicator because you will listen more and you will hear the other person and you will see where they're coming from, what are their either challenges or concerns, and you'll be able to address them. So active listening is a crucial part of communicating. Communication is a two-way street. And the last one is having difficult conversations. And here I mean mostly in the work environment. This is what I'm focusing on at the moment. And those are the conversations where something is happening or has happened, and you know it's not going to go away, and you don't need to go to that person, and you have this gut-wrenching feeling, and you think maybe it will be better, maybe if I don't do it, I don't know. But it never gets better. And someone has to do it. Someone has to stand up, has to talk to that person. It can be a performance review, it can be receiving or giving feedback, or it can be inappropriate behavior you need to address. And there are ways to do this. There are good resources online, good books about this, how to have those kind of conversations. And those are crucial conversations that will change the relationship you have with that person. And depending how it goes, it's going to be better or worse. But it's really important to have that conversation. And one of the good books is the Radical Candor, I can highly recommend. The next one is creativity. And let's define creativity for the purpose of the talk as the ability to come up with new ideas. Being innovative. And there are two sides of creativity. The first one is conceptual. And conceptual is when you combine ideas from a different field. An example I have here is, this is Shinkansen, a bullet train in Japan. And some of the early versions they had, when it was going through the tunnel, it was so fast that it was compressing the air, and when it exited the tunnel, there was a sonic boom. It was very loud, it was not very pleasant for people living around there. So they tried to find a different design to solve it. They couldn't find anything. One of the engineers was a bird watcher, and the bird here is a kingfisher. And this bird flies and then spots a fish in the pond, and it goes down into the water and grabs the fish, and it makes a minimal splash. So it turns out that the beak of the bird has a special property. It's designed in a way that has minimal, it has the best properties for going through something that's really dense. So they tried to model different shapes of the front of the train, and actually the one that was closest to the beak was the best model. It was very silent, there was no sonic boom anymore. So this is conceptual creativity, where you can combine different ideas and make something new. The second part is evolutionary creativity. It's a more of a, okay, this is the idea we have, and how can we continually improve it? And I think browsers are a good example of this. So with every new version of browser, there are incremental changes that maybe are not as dramatic, they are not great. But when you look at 20, 30, 40 updates of the browser, when you look at like how it was 5 years ago, you can say, wow, this has really improved. And those two are not exclusive, so you can combine them together. But there are different things important for different types of creativity. But with creativity in general, the problem is that it's only for young people, right? Even Einstein said that if you don't do anything by the age of 30, why even try? And you look at the Silicon Valley, all the founders are really young, it's like 18 to 25. All the musicians, new stars, are very young. So it seems like creativity is only for young, right? What about us who are getting older? There's an interesting study done a couple of years ago, and they looked at the last 200 years of scientific publications. And they looked at if you publish something at the beginning of your career, middle of your career, or end of career, what are the chances of this paper to be a successful one, or maybe even getting a Nobel Prize? And the conclusion is that it doesn't matter. It doesn't matter when you publish. You can publish anytime. You can publish at the beginning, at the end. It has the same chances. So was Einstein wrong? Not really, because he was observing what was happening around him. And it turns out that even this paper, they actually show that mostly young people publish. And when scientists get into their 40s, 50s, they actually start publishing as much. So just by looking at numbers, it's more likely that your paper is going to be very significant when you're young. So what happens there? Do we get older and just give up? Do we just say, oh, I've been doing this for so many years, I just won't try anything new? Sort of. Again, interesting studies done in the 90s, which is what they did. They tried to look at people, how they perceive time. Does time affect the way they think about the future, about knowledge, about innovation? And they found out that when time is perceived as open-ended, people will prioritize knowledge goals. And if you perceive that your time is limited, then you will focus more on your emotional goals. And in the study, they had very young people and they had very old people, so in the 70s and 80s. And of course, people who are a bit older, they're focused more on their family, on their relatives, on their own needs. While younger people are more open to new experiences, meeting new people, trying something new, trying new food, reading an interesting book. And as we get older, we sort of close down and say, oh, okay, this is my group of people, I'll just focus on them. But what was interesting in the study is that they could reverse this. They could put people in a position where younger people would feel, oh, actually my time here is limited, I'll just focus on myself. And the older people were being more open. So it seems like it's more of the mindset shift. It's not something biological that is happening. So to be really good at creativity and conceptual creativity, what you need to do, you need to be exposed to different ideas, exposed to new people, to new experiences. So it's not one skill you can practice, it's more of a, how do you create an environment in which you can be creative? And this is hard, right? It's hard to always start something new. It's hard to always meet new people. It's hard to read books that you usually wouldn't pick up. But it's necessary. It's necessary to be in this environment when there is always a flux of new ideas. And be aware that as you're getting older, there'll be a stronger pressure for you to not do this. So how do you keep this very open? For the second type of creativity, Linus Pauling said, of course, to have a good idea is you need to have a lot of ideas. You need to be aware of a lot of ideas. For the evolutionary creativity, the only way to actually further the field is to be a master in your domain. And this ties nicely into what we discussed earlier about the domain skills. It's really hard to improve something in computer science and software development if you know only the syntax of Python. You really need to become the master of your field to be able to improve it. And there was an interesting example from Andrew Ng, who is a co-founder of Coursera. He worked in Stanford and Google and Baidu. And he's a very famous person in the machine learning field. And one of the conference, the people asked him, what do you recommend new people who want to become machine learning researchers to do? How do we become a really good researchers? And he said, I always have a ready answer for them, and they never listen to me. And I know the answer is working. And the answer is this. Take existing research and copy it. Try to reproduce it. It has a couple of benefits. The first one is you read something that is done, you try to understand what was the person thinking, you go through the motions, you repeat it, and you get the result. And then you can compare it with the result of the study. And you can see, is this correct or not? It's a good feedback loop. And you do this once, twice, 3 times, 10 times, 20 times, and you will just copy and copy and copy. But over time, he says, at some point, you will have your own ideas. You will take another study and say, actually now I would like to do this in a different way. I think maybe a different approach would work. And this has been a consistent theme throughout the human history, is how we learn. Apprenticeship, Eastern traditions, where you would learn something and you will learn it to the point where you forget about it, you don't have to think about it, and only then you can create something new. Think about sports or dance. If you start something new that's very physical, you cannot just go out in the field and play it. You first have to learn the techniques, and only when you become really good at this, you can create something new. So it has been a consistent theme how to attain mastery. You copy others, and at some point you internalize it, and then you can create something new. So to be really creative in any kind of field, attain mastery, and then you can push it forward. Peak is a really good book about deliberate practice. And you probably haven't heard about the book or the author, but the Malcolm Gladwell and Outliers and his 10,000 hours to become mastery is taken from the research of this guy. And the 10,000 hour rule is it sort of works, but there are some nuances to it. And I think that this book is a really good resource to understand what is the difference and how to get there. Collaboration. There is cooperation, which is when people support each other's goals. And there is cooperation, where people support or they try to achieve a shared goal. And to have collaboration, there is always some leadership involved. And leadership is such a lofty term, and it's thrown around a lot. And I've been trying to really define it, and I wasn't able to. But then I found one definition I really like, that I'm really passionate about. And I'll read it out because it's important. Leadership is all about having a point of view and bringing people along. It's about being responsible for an outcome. And I think this last part, being responsible for an outcome, is the critical part here. It doesn't imply that leadership is a person standing on top and directing others what they need to do. It's just you want to see an outcome happen. And this means that it can be a more fluid relationship with leadership. Sometimes you lead, sometimes you follow. Especially today, especially you as knowledge workers. There are situations where you know that someone else is a better person to maybe lead the stage, and so you hand it over. And being very adaptable and fluid in leadership is important. Of course, influence. And influence, because it can happen that people have the same goal by chance, but usually people pursue their own goals. And there needs to be some kind of influence so that we all support the same goal in an organization or a team. And just to be clear, when I say influence, then people say, oh, it's manipulation. You're lying to people. No. Just to be clear, influence is affecting someone's behavior, but you are being very open about your intentions, and it's for the benefit of both of you. While manipulation is also affecting someone's behavior, but you're hiding your intentions. And then you're using this person as a means for your ends. And this is, of course, bad. But influence is good, right? I think that this is the best way forward. Let me give you my arguments. Can we agree on this, that we both will benefit? And then we do it. And it's good for us, it's good for the team, it's good for the company. So that's influence. But influence is also hard, especially if you're not the boss. And sometimes, not sometimes, most of the time, you need to influence people who are your peers, who are your colleagues. And that's hard, you know? You all have been in situations where there's this person and you want to do this, you want them to do something and then don't want to do it, but there are ways to do it. And you can look it up. It's called Cohen-Bradford model of influence. It's a really good model of how to think about influence where you don't have authority. And there are certain techniques and ways of communicating that can achieve what you want for the benefit of both of you. Trust is the result of when leadership and influence play together well and when you have a good outcome. So you have trust, and trust is a cycle, it's a feedback loop. When you have a lot of trust, then it's easier to influence and it's easier to lead. And then you will do and have a good outcome, and then you'll have better trust again. But you can ask yourself, what if I come to an environment when there is no trust? Nobody wants to help each other. And that's tricky. Luckily, Robert Axelrod, he's a political scientist, and he did some interesting research in the 80s around game theory. And he showed that there are situations where you can come to an environment when there is no trust, but if you set up an environment in a specific way, the trust and cooperation can emerge from nothing. And there's a book, there's a scientific paper about this. I highly recommend to read it. If you're not into reading, if you're more into maybe web games, someone made a half-an-hour-long web game where you can learn all about trust and how people work together. And just in general, as a collaboration, because you'll be working with more people, you need to coordinate them, it's really good to have project management skills. You don't have to be a professional project manager to have those skills. In the same way, you don't have to be a professional writer to write well, but being able to manage project risk estimates, I think it's a good skill to have in general. The last part is critical thinking. And I think this is the one that took me the most time to really understand and to clarify in my mind. And again, just to be clear on the definition here, I mean that critical thinking is a process for evaluating information to form a judgment or to make the best decision under the circumstances. So how do we form a judgment or make a good decision? So what are the components parts? And I came with 3 things. The first one is, to be a really good thinker, you first need to know where you fail in thinking and perception. Why is your brain doing things that it's doing? Why is it a pattern recognition machine, and why is it trying to fill in the gaps? And why it's willing to take in beliefs and misinformation from around and just fill in those gaps? Let's take an example. Oh, sorry. There's a list of, they're called cognitive biases. So this is you can find it on Wikipedia. There are about 200 of them. You can find there are around 200 of them, and they describe all the ways your thinking can fail. And you don't need to know them all by heart, but it's good to go through them, because next time you'll be thinking about something, you might catch yourself. And you might say, oh, actually, maybe I'm failing in here, so you can take a step back and think about it a bit more. And one of the examples of the cognitive bias is here. So let's imagine that Linda is a 30 years old, single, outspoken, and very bright. And she majored in philosophy. And as a student, she was deeply concerned with issues of discrimination and social justice. And she also participated in anti-nuclear demonstrations. The question is, which is more probable? Linda is a bank teller, or Linda is a bank teller and is active in the feminist movement? And if you're like most people, you immediately said number 2, right? It's just a more vivid description of Linda. It pulls you to the description of Linda. And if you don't think about it, you will say number 2. And it makes sense, right? It matches perfectly with how we describe Linda. But then if you look at this, like this circle contains all the bank tellers. And then there is other circle that contains all people that are active in the feminist movement. And you can see that the overlap is very small. So the question is, which is more probable? That Linda is a bank teller, or that she's a bank teller or active in the feminist movement? It's more probable that she's only a bank teller. And it's hard to catch. And there are many examples, even more subtle examples, where we all fail. People who have devised this experiment and people who are really good at statistics also fail in this when they don't think. It's just a natural inclination of our brain to jump to conclusions like that. And you need to catch yourself. So this example was taken from Thinking Fast and Slow from Daniel Kahneman. And he and Amos Tversky did a lot of experimentation about human cognition in the 70s. And Kahneman even got the Nobel Prize for this. So highly recommend it. The second component is just logical reasoning. Deduction, induction, so inference in general. Being able to link arguments, to evaluate arguments, to make a conclusion. People have been doing it for 2,000 to 3,000 years now, and some of you had it in school, some of you haven't, but there are really good books, online resources, classes where you can learn about logic. And the example with Venn diagrams I showed before it's one of the reasons how you can logically think about the problem. And it's a component part of being a good decision maker, a good critical thinker. And the last part is, let's call them mental models. And mental models are representations of how things work in the world. as I said before, there's so many domains, and you will not be able to know the details of everything. You will just not. You will be able to know the details of your domain, but there's so many things in the world, so many different industries. And you need to know about at least the high level. You'll need to know the high level understanding. And mental models is a part of that. And one of the really good resources for that is Farnham Street blog. And he has a list of more than 100 mental models. It's not all of them, it's just some of them that are listed here. And they are bucketed in a couple of categories, like general thinking, numeracy, microeconomics strategy. And for example, numeracy is a really good one, is about how are we good with numbers, statistical thinking. So we humans are generally really bad at statistics. So it's really good to know things about statistics and combinatorics. Or about economy, microeconomics, macroeconomics, how things work in general. You don't have to be an expert, you don't have to know all the details, but just having a rough mental model that you can update over time is really important. And if you know a lot of things, and you know how your thinking can fail, and you know you're good at logical reasoning, then you have all the tools to be able to evaluate information you get from the outside, from the internet, from other people, but also for you to make a decision or a good judgment. Some of the examples for how to build good mental models is thinking in systems. I mentioned a couple of times. It's a good primer where you can learn about how different systems work in general. And also Behave from Sapolsky. It's a compilation of neuroscience work that is sort of accessible to our mere humans, so we can understand it. And it talks about how our brain works, hormones, why are some things really hard or really easy in human communication and behavior, how do we form us-them beliefs, how trust forms, things like that, just how humans work in general. So going back to the question from the beginning, is how do we prepare for the future that is unknown? And I think the answer lies in understanding where all skills lie on the spectrum of change. Some skills, like on the left-hand side, like the foundation, the trunk, they're so closely tied to human biology or culture that those skills will change only when we as humans change significantly. On the other side, there are skills that are very situational. They're very job-specific. And they will change constantly for many reasons. So you will need the skills from the whole range. But as you think what you're going to invest your time in, I think it's better to invest time in more in the left-hand side and in the middle. Things that will last for years or for decades. And those skills are usually not the ones that you will get any instant gratification. It takes time to learn them. And that's why your natural inclination might be, oh, I don't want to do this. I might want to try this new VR stuff. It's so cool. And I don't want to spend 3 years improving my writing skills. But most of the things you've done in your life that you're proud of took time and were hard. So as you think what's next for you, think about if you want to nurture your tree of knowledge, or will you end up with just a pile of dry leaves? Thank you. If there are any questions, we can answer them. If not, we can also, I'll be on the sides, and you can find me. I'll be here for both days. I'd be happy to talk with you about this. It's something I'm really passionate about. So please just find me and let's chat.
Hey, so this will be a prime example of a cognitive bias, but who is the author of that quote in leadership, the very wise person that you mentioned?
I wasn't able to find it. So it's one that someone at Google put it up there, and I wasn't able, like probably some multiple people talking about it and writing it down, so it's not one person, and I wasn't able to track it down. I tried to, I couldn't find it.
Hello, my name's Kyle. I'm interested in what you're talking about regarding mental models and some of the other components of UX that don't often come up a lot. And I was just interested in what what you think UX actually means and what it has to include, and where you draw the line between what developers should know and understand and think about versus what starts going into the research and academia area.
So just to repeat, like, what does UX mean, and what is the difference between development and UX?
Between the parts of UX and like human factors in general that go into development versus what is more research focused and academic.
Mm-hmm. On a very high level, I would say that what goes, like, research is basically building the technology for the next 10, 15, 20, 30 years. But then everything else is, the technology that is used today to solve real world problems is just nothing. Research is basically what you would use to develop the application. UX. So I mentioned Mythical Man Month again. So they didn't have UX people in the 70s. And what's interesting is that the author talks about how do we go out to people who will use our software and build the software for them? How do we build a specification? How do we build product requirements for them? And this is developers going out there and doing this job. So I think just realizing that you as developers or designers or project managers, you're building software for humans, for people, is really important. And yes, I work as a software developer, now I work as a UX designer, so there are those two separate roles. But I think it's important for everyone to understand you're building tools for humans, and there might be more people who are going to specialize in UX, people who are going to specialize in software development, but it's something that all people should strive to do.
Hey Merlin. Oh, this works. Thank you for the nice talk. I have a question. So you were talking about skills that we were gonna need for our future job, etc. What about the skills that make us happy? How to strike a balance between professional skills and skills that make us happy?
That make you happy, skills that make you happy. So when I look at like what I'm trying to learn, and also when I talk to people to try to help them decide what to learn next, it's usually a couple of questions I ask myself. The first one is what I'm interested in, of course. Then how the environment around me looks like. Because if you're in a specific environment, you can learn more things. For example, if you're working in a restaurant, it's going to be much easier to learn cooking skills than, I don't know, brick building skills, right? So depending on what kind of company you work in, there'll be some skills or people who are more available than someone else. And then also, what are the skills that are needed for you to progress to the next stage of your job or career you're looking for this? And I try to find an overlap. Is there something that I'm really passionate about, I want to learn, that is available in my environment, and I'll have people who will support me in this? And that's the ideal scenario, right? This doesn't happen all the time, so you'll have to make a compromise. There isn't a good answer, but I think being really clear that there are these different factors going to the decision, and then you can decide what you're going to prioritize. Are you going to prioritize your current environment and the opportunity, or something that you're personally passionate about?
Hi. Hello, hi, thanks for the talk. So I think that your talk involves a lot of philosophy and psychology and a lot of branches that aren't technical, and your approach to non-technical skills is really academic and professional, and it's a similar approach that a lot of us take for technical skills, but not for soft skills. So how did you come about having such a professional approach to soft skills? And how would you advise us, developers, to approach those skills in a similar way that we approach technical skills?
First of all, I also did the same thing before. I tried to separate them into soft skills and hard skills. And I think the separation is not very good because when you hear soft skills, it seems like they're weak, right? And hard skills is something you have to do. It's not the same thing. I would actually say these skills are much harder to learn and to practice than any of the technical skills. And just to give an example at Google, so when you come to Google as a junior developer, junior software engineer, or even junior designer, right? You are expected to do things that are very technical, very specific. And then as you grow, as you become better in this, you will come to a certain level where you can do your job. You have those technical skills. At some point, you will need to work with a broader group of people to accomplish something. And it's impossible to do this well if you don't have everything I mentioned here. It's just impossible. You cannot be a very senior, very senior engineer at Google and not being able to collaborate, not being able to write or to communicate or to present or to think critically. It's just impossible. So I think the good mindset shift for all of you should be, this is not something that I learn in addition to get by. It's something that's core to any job you have. And it's going to be an amplifier to all other technical skills you have. I think this is a big shift for me. That's also the reason why I did this, because in the last 5 years, I tried to shift my perspective. This is not something that is, again, an addition on the side, something some people are good at soft skills. It's a critical component of your professional development.
Do we have any more questions, maybe? Okay. If not, thanks, Merlin.
Thank you.